welcome to another video. All right, today we have this nice problem to solve. This is electric field. We have electric field problem. So now we have an electron is shot at 10 raised to the power of 6 meters per second between two parallel charged plates as shown in the figure below. So we have two parallel plates. One plate carries positive charge, okay? Now the other plate carries negative charge, okay? So now for this plate, now the distance between the two plates is given to be 0.5 centimeters. 0.5 centimeters. So then, so we're also given that if E, that is the electric field intensity, okay, between the plates is 1 kilonewton per coulomb. So where will the electron strike the upper plate? That is, when the electron is shot, okay, it travels at a speed of 10 raised to the power of 6 meters per second. That means it moves with a speed of, that's velocity of 10 raised to the power of 6 meters per second before it is what? Deflected. Okay, before deflecting towards the positive plate. Okay, now it will deflect towards the positive plate because we know that unlike charges will attract each other. All right, so now when it deflects towards the positive plate, before deflection, it moves or travel some more like horizontal distance before deflection. So when it deflects, okay, now the deflection will be what? Will be in the vertical direction. That's, it will be upward. So which means this problem is what? Is clearly a projectile problem. All right, in a way. So now let's first identify the parameters we're given. Like I said, this is clearly about a projectile problem. All right, so the first thing is, now we can say here that taking upward, okay, taking upward as positive, taking upward as positive, and then using E, we know that the charge on electron is 1.602 times 10 raised to the power of negative 19. So that will be 1.602 times 10 raised to the power of negative 19 coulombs. Now then also we know that the mass of electron is the 9.1 times 10 raised to the power of minus 31 kilograms. Now we're also given the electric field intensity between the plates, which is 1 kilonewton. So which means E is 1 kilonewton per coulombs. The unit of electric field intensity is the what? 1 kilonewton per coulombs. Now also we are given the what? The velocity of the electron, which is 10 raised to the power of 6 meters per second. 10 raised to the power of 6 meters per second. Then the electric field intensity is 1 kilonewton per coulombs, which is same thing as what? 1000 newton per coulombs. All right, so now with these informations, we should be able to calculate or to find out where the electron will strike the upper plate, which means the distance. You know, you can see we have it as x here. So which means at what distance will the electron, you know, strike the upper plate, which is the what? Positive plate. So first thing first, okay. Now let's analyze this problem. All right. The electron is shot at a speed of 10 raised to the power of 6 meters per second. Okay, that means the electron will be accelerated. Now the force on the electron, that is the electric force on the electron, because we have an electrostatic plate. Okay, one plate carries positive charges, the other plate carries what? Negative charges. So which means there will be an electric force on the what? Electron. So the electron, the force now develops an acceleration on the what? Electron. That's according to Newton's second law of motion. So which means first we know that the electric force is the electronic charge, or the charge on the electron, multiplied by the electric field intensity. So then we know that according to Newton's second law of motion, now we can set this to be equals to, so we can have the force on the electron, which is electric force, will be equals to ma. That is the force accelerating the what? Electron. So we are going to set these two equal. So we have MA, okay, MA, so which will be mass of the electron and its acceleration, then equals to the charge on the electron multiplied by the electric field intensity. So now, in this case, when we rearrange this equation, we're going to have this to be E, okay? That is the charge on the electron multiplied by the electric field intensity over what? Mass of electron. So now, let's calculate the acceleration. All right, so to calculate the acceleration, so we know that the charge on the electron is 1.602 times 10 raised to the power of negative 19 multiplied by, now the electric field intensity is 1000, which is same thing as 10 raised to the power of 3, okay, over, now the mass of the electron, which is 9.1 times 10 raised to the power of negative 31. Now the unit of electron acceleration is the meters per second square. All right, so now let's divide 1.602 by 9.1. Okay, so what is 1.602 divided by 9.1? Okay, that will be 0.176. So acceleration equals to 0.176 multiplied by 10 raised to the power of negative 19 plus 3. Then this will also be added to the powers of 10. So that will be plus 31. Then we have meters per second square. Okay, so we can then write this will be 1.76, okay, multiplied by 10 raised to the power of negative 1. That is when we move the decimal point, okay. Now 31 plus 3, that will be 34. Now 34 negative 19, that's plus 34 minus 19, that will be 15. Okay, so this will be multiplied by 10 raised to the power of 15, then meters per second. So the acceleration will be 1.76 times 10 raised to the power of 14 meters per second square. So this is the acceleration, okay, that's the acceleration developed on the electron. That's the electron. Okay, all right, so now, so the next thing we need to also look at is, okay, now we've been able to calculate the acceleration. But now, what another thing that is important here is we have the distance between the plates to be 0.5 centimeters. So which will be the vertical distance. So in this case, we are going to have that for vertical motion, for vertical motion. First, we must know that that's the initial vertical velocity or component of velocity, okay, will be equals to 0. So we have the vertical distance to be 0.5 centimeters, and that will be 5 times 10 raised to the power of negative 3 meters. 0.5, that will be 5 multiplied by 10 raised to the power of minus 1. Then centi. Centi is one of the prefix used in physics, and we use it to represent 10 raised to the power of negative 2. So 10 raised to the power of negative 2 multiplied by 10 raised to the power of negative 1. That will be 10 raised to the power of negative 3. So that's why we have this to be 5 multiplied by 10 raised to the power of negative 3. All right, so now this vertical distance, so using one of the equation of motion, we know that for vertical motion, when we know that the initial vertical component of the velocity is 0. So we know that this will be uy times ty plus 1/2 of aty squared. Now, why is it ty? Now, that means the time taken during the vertical motion. Now, we have it here that the electron is shot at a speed of 10 raised to the power of 6 meters per second. Okay, now when the electron is deflected, so it moves upward and then strikes the positive plate. Okay, so which means the time taken, for the electron to hit the upper plate is ty. So it moves in the vertical direction. All right, so which means in this case, so we have 5 multiplied by 10 raised to the power of negative 3. This will be 0, yeah, because we have uy to be 0 here. So we have 1/2 of this acceleration, 1.76 times 10 raised to the power of 14, then ty raised to the power of 2. Okay, so now let's multiply this equation by 2. So multiplying this by 2, that will be 10 times 10 raised to the power of negative 3. Okay, multiplying this by 2 will reduce to 1.76 times 10 raised to the power of 14 because 2 will cancel out. So then we have ty raised to the power of 2. All right. Now let's get the value of ty. So when we rearrange this equation, we're going to have ty squared to be now 10 raised to the power of 1 multiplied by 10 raised to the power of negative 3. That will be 10 raised to the power of negative 2 divided by 1.76 times 10 raised to the power of 14. That is, we have to divide both sides by 1.76 times 10 raised to the power of 14. Okay, now we'll get there. All right, so from here, so we have ty squared, okay, we have ty squared to be equals to 10 raised to the power of negative 2. Now I can bring this 14 here, then it will become negative 14 divided by 1.76. Now ty will be equals to the square root of 10 raised to the power of negative 2 minus 14. That will be 16. 10 raised to the power of negative 16 divided by 1.76. Now, we know that the square root of 10 raised to the power of negative 16, that will be 10 raised to the power of minus 8. Yeah. So we have ty to be equals to 10 raised to the power of minus 8. Now, let's get the square root for 1.76, and that is 1.327. We have 1.327. Okay. Now, what is 1 divided by 1.327? Okay, so 1 divided by 1.327. Okay, that will be 0.754. All right, so this will be ty equals to 0.754 multiplied by 10 raised to the power of negative 8. This guy. So this is the unit of this is what? Seconds. So that ty will be equals to, so let's move the decimal point. This will be 7.54 times 10 raised to the power of negative 1 times 10 raised to the power of minus 8. Now seconds. So ty will be equals to 7.54 times 10 raised to the power of negative 9 seconds. All right, so that'll be negative 9 seconds. So this is the time taken for the electron to strike the upper plate. Now, because we want to find out where will the electron strike the upper plate. So that's at what point? Now it strikes the upper plate at this point. So the distance from this point, okay, to this point, okay, that's the separation from this point to this point is what we have as x, which will be the range it travels, or the horizontal, distance. All right. So for horizontal, so we then consider that for horizontal motion, remember the velocity was shot at a speed of what? 10 raised to the power of 6 meters per second. Okay, so that's the horizontal velocity. So we have the horizontal velocity to be equals to the distance over what? The time it takes the electron, to strike the what? The upper plate. So this ty. So we then have x to be equals to, okay, so I can actually leave this as t. So we have Vx equals to Vx times t equals to x. And then we know that Vx, which is 10 raised to the power of 6 meters per second. So we then have x to be equals to 10 raised to the power of 6 multiplied by this value, 7.54 multiplied by 10 raised to the power of negative 9. Okay, so the unit of this will be what? Meters. So x will be equals to, so when we combine this will be 7.54 times 10 raised to the power of 6, 10 raised to the power of 6 minus 9. The unit will be what? The unit will be meters. So we have 7.54 times 10 raised to the power of negative 3 meters. So this is now, so which means the electron travels distance 7.54, okay, times 10 raised to the power of negative 3, which will be 0.754 when converted to, we can say, or, okay, yeah, that will be 0.754 centimeters, okay. So before it is deflected to strike the upper plate of the electrostatic plate. The noblest pleasure is the joy of understanding. Bye bye.